Hello, I was recently looking to find a YouTube video that demonstrates how to create a custom dependency container application like the one that Spring has, but I only managed to find such videos for C#, so I decided to make one for Java myself. And the reason I want to create that video is because there are a lot of videos on the internet explaining what the dependency container does, but they don't go deeper explaining how it does it and what's the logic behind. And for me, the best way of learning something is to understand actually how it's been made. So in our case, that would be we're going to create a custom replica of the Spring Boot dependency container, so hopefully that will help you understand. So in this tutorial, we're going to build the application from the ground up without using any third-party libraries. The app is not complex, but there will be but quite a few challenges, so a lot of reflection and some edge cases. Also, if you have any questions, you can comment down below. I'll answer them as soon as I can. The code will be uploaded to GitHub after the video is made. And also, one more suggestion, I suggest you watch a video in 1.25 speed because I tend to talk a little slow. That's because English is not obviously my native language, so it seems if you watch in higher speed it looks more smooth. Okay, so let's quickly go and see what exactly the application is going to be about. So I have opened here IntelliJ, that's a simple Spring Boot application, just to demonstrate what we're going to create as an app. So we're going to have as well services. Those services are going to rely on some other third-party libraries. For example, we're going to have beans as well, like this one, and then we're also going to have those post-construct and pre-destroy annotations. So basically, when we fire the application, this is the result is going to be similar. Those dependencies are going to be automatically resolved. Like you see here, we are depending on interface, but Spring Boot knows that we are actually looking for the implementation, so we're going to make that work for our custom application. So that's pretty much it. Now let's start building it. Quickly before we begin, in order to make the process a little more understandable and easier to follow, we're going to split the application into 5 different subtasks. So it will be like a little milestones. So those subtasks are going to be creating the project, locating classes, mapping those classes, making the instances, and then creating the dependency container service itself. So let's start first with creating the project. So let's create new project, new Maven project, com.demo. Let's call the application Magic Injector. Version 1. Okay, that's fine. Okay, so let's just create the first packages. Let's just make it like that to be a little shorter. Now, what we're going to be needing throughout this video is going to be Maven. So if you don't have it installed, just go to Google, search for Maven download. So just download the binary zip file if you're using Windows, and then just when you're done with this, you just go save it somewhere. In my case here, Maven, and then just add it into your environment variables. So for me, that is, you can find it right here in the bin folder. So once you've done this, when you open the command prompt and type Maven, you're going to have Maven installed. So with that being said, let's continue here. Now first let's just set our Java version. So this is going to be actually our startup class, but I currently need it just to say, if you're using IntelliJ, that's a quick way for changing the version of your Java, like that. So actually we are not going to need a main method for our application once it's done, but for now we are going to have it just so we can test what's going on. Okay, so let me just add this Maven plugin. This is for creating the jar executable. Also, we're not going to need this in the production, but once we're ready. But right now we're going to need it just to test both cases for directory and jar. I'll explain a little later. Okay. Okay, so let's create the packages that we are going to need. So the first package is config constants. Are there any more? I don't know if there are any more needed. We are going to create them as the video goes on. Okay, so now let's move to actually creating our entry points of the application. So public static void run class startup class. So startup class we are going to need for two reasons. The first reason is that we're going to use this class to find, because we're not using this library, we're going to use it as a dependency, so we need the actual directory that our final application is stored. So startup class will help us locate that directory, and also we need the startup class for another reason, which is after we're done loading everything, we are going to execute a method from the startup class to let the client know that we're done with the build process. So that's why these are the two reasons why we need the startup class. Also, we're going to have configuration. So let's go to config and let's create a class named magic configuration. Let's leave it empty for now. We'll go to that. Okay, so those are going to be our main starting points. So let's just run magic configuration like that. Okay. So basically I think that is it for the actually first part of the process. So let's go to the second one, which is locating classes. Okay, so let's continue with creating classes. Actually I just forgot to add two more packages, annotations and models. Okay. Now, what I mean by locating classes is that currently we don't have any information about the classes that are in the application. So in order to do that, we actually need to sort of reverse engineer this. We need to get the directory in which those classes are currently residing, and we need to start scanning for them, and then using reflection we can load them into a into our context. So in order to do that, there's a little functionality from the class itself, which is get protected domain, get code source, get location, get file. Let's just print that to like that. So let's just print it to show you exactly what I mean. So let's just run the application first, actually, as a startup class. Let's just put this one and run. Okay, so you can see that directory is that thing here, classes. So you can see that we just got the root directory of the whole source code itself, not the full path to our class. So this is great. That's exactly what we need, because we need to start scanning from here all the way through those folders to find every class that is available. So the other case is that this directory can also be a jar file, because you know that Java has executable jar files, so those are not extracted anywhere, they're just ran from themselves. So we need to keep this in mind as well. So let me just show you how it looks like. So you remember that little plugin that I added here? So now if you go to the terminal and we type Maven package, you can see that here another jar file will appear. So we can just right click and open in terminal, and let's just type java jar magic injector.java. Sorry, forgot to specify the version. Okay, so you can see that directory is different now. It's a jar file. So moving forward, we'll have to keep this in mind for when it comes to actually scanning the class files. So with that being said, now let's create a service that will help us define and sort of see what type of directory we're working with. Okay, so let's first create an enumeration and call it directory type. So we're going to have two types, directory and jar file. Okay, now let's go to models and let's create one model called directory. It's a simple class that is going to have directory, and it's going to have directory type. By the way, if somebody is wondering, I'm pressing Alt and Enter for all those pop-ups. Let's create the getters like that. Services, let's create a new service. Let's call it directory resolver. Okay, so that service is going to have one method. Is going to be called, let's just start with actually directory resolve directory. It's going to accept the startup class. So startup class. Okay, so let's go and create an implementation for that service. And by the way, I really I like doing that. I mean, it might sound stupid to have just a class with simple one method and have an interface for it, but that's the way I like to build my application. So yeah, we're doing it that way. Okay, directory resolver, implement the method Okay, so we're going to have one private method for actually getting the directory. So get directory, and this is going to do exactly the same that we did here. So basically, let's just copy that and return this. So return final string directory equals get directory, and then return new directory from this. And now we need to create another private method, directory type, get directory type from the directory that we already got. Okay, so this get directory type directory. Okay, so what we need to do here is, as I showed you, we have two cases. The one is the jar file and the one is the directory. So we need to see which time is we have a jar file and which time we have a directory. So in order to do that, let's just convert this string into file. So file equals new file directory. And now if this file is if it's not directory and directory ends with .jar, so basically in every case that we have a jar file, it's going to end with .jar. We can return directory type .jar file. Otherwise, we can return directory type .directory. Okay, so can I extract this? No. So I want to create this into constant because it doesn't really seem okay like that. Java extension, Java extension. Okay, now it looks much cleaner. Okay, so I think that's pretty much it for this service. So let's go back to the startup method and let's say directory equals new directory resolver dot the result directory. So let's just print the directory type and see if we did it right. So running it with the folder, we should get directory. Yeah, so we got directory. Okay, so let's try to build it and see. I'm switching here to Woco to be able to call Maven package. And I'll go to the other window to call the Java command to run the jar file, and you can see that we're getting jar file here. So the service is working properly. So now we need to go further into creating the service that we will actually load our scan our classes. So the service that we're going to create is going to be called class locator, and it is going to have a method set of class locate classes, and here it's going to receive directory. Okay, actually it doesn't need to receive directory, you can receive string directory. Okay, so also I wanted to throw an exception just for the user to know if something is wrong. So let's create a new exception and call it class application exception. Exception. We're not going to make it checked because this is sometimes annoying, so let's make it unchecked. Okay, so throws plus location exception, like that. So for this interface we're going to have two implementation, obviously, one for the directory type and one for the jar file type. So first one was locator for jar file. Like that. And the other one is going to be class locator for directory. Okay, so I would suggest to start with the jar file because it seems it is a little bit easier. It doesn't have recursion functionality in it, so let's go with it. So we're going to have a set of class which we're going to call located classes equals new hashtag, and finally we're going to return those classes. Okay, so let's go and create a jar file object. Jar file from new file from directory, like that. So there's an exception that we need to catch and throw new class location exception, just to solely throw the exception for the user to be not notified. Okay, so what jar file object has is a thing called entries, which by the way I'm pressing Alt and Enter for this to introduce local variable. So we have enumeration from jar entry, which is really cool because we can iterate this now. Wow. Has more elements. We need to get next element, sorry. So this jar entry might be class, it might be image, might be everything that you can find in a jar file, jar package, might be the manifest or something like that. So we need to check here if the jar entry is class. So in order to do that, we can say if jar entry get name ends with dot class. Actually, if it doesn't end with dot class, just continue. Otherwise, we have, and I'll actually just print it for you so you can see what we are actually getting. So jar entry dot get name, like that. Okay, so let's just test it and show you what exactly we're getting here by doing this. So here we're going to have class locator equals new. By default is going to be class locator for directory, and if directory get directory type equals directory type dot jar file. In that case, our class holder will be a new class locator, not class holder, sorry. Okay, so let's just call class locator locate classes, like that. And let's just print those classes. Okay, so running it from a directory, we should get no. Okay, and now doing it from the jar file, let's see what we're going to get. Oops, we have error. I should have switched to the other window. Okay, so running it now. So we see we get an empty array because we are not adding anything to it, but here are the files that we are scanning. So those are all the classes that were found in that jar file. So what we need now to do is we need to load those classes. So but you can see that there are dashes here instead of dots, and you know that if you want to load a class in Java with class for name, you need to specify the namespace, and namespaces with dots rather than slashes. So that's pretty much easy fix. So class name equals entry get name, replace all, actually, yeah. But yeah, also sorry for forgetting that. Also, we need to get rid of this .class extension, because also that is invalid name. We only need this name. So replace .class with nothing, and then replace all, and we're replacing all the backslashes with a dot, and just in case we're replacing all forward slashes with a dot. So now we can easily say class for name, class name. Also there's an exception thrown here. We'll have to surround this with try catch and rethrow the exception. So class location exception. Actually no, we can just add it here. It should be a bit easier like that. Yeah, looks better. Not class location exception, but class not found exception, like that. Okay, introducing into local variable. No, actually we are just going to say located classes at, like that, because I'm pretty sure if the class name is present in a jar file, it will load it, no problem. Okay, so the implementation for the jar file should be fine, but I don't like that .class that I just created, so let's create a constant class like that and say public static final string Java binary extension equals class, like that. Okay, so constant Java binary extension, same thing goes for here, like that. Okay, so I think with that our jar file implementation is ready. Let's go to the directory one. Here is going to be a little more tricky, I guess, because there's a little more algorithm involved here. So let's just check first if this is really a directory. So file equals new file directory. If file is not directory, throw to new location, class location exception, yeah, sorry. And we can say here invalid directory message. Like that. So we can actually go string format. Like that. Okay, so once we are sure that this is a directory, we can actually call one method which is going to be called scandir. This will take as a param file and also string package. I'll explain why we need that in a moment. So this, this Candir file and an empty package. So here we need to check if file is directory and if it's not. So if it's directory, we need to call, basically we need to iterate those, what was the method, list files, yeah. So we need to iterate all the files inside this subfolder or folder, and we need to go deeper inside to see if there are any more classes. So let's just go Scandir here with the inner file, and the package name is going to be, basically we're starting with an empty package. So here we just need to package name, we need to append the package name with file.getName plus dot. That way we're starting to build the package name for the class, so we can then load it properly. Okay, so here we just pass the package name like this, and if it's not a directory, then it's a file. So we need to check here if the file is a class. So if the file.getName ends with constants Java binary extension, if you remember that we created this. So if it's not ending with this, just return. Otherwise, final string class name equals package name plus file get name. So let's just print the class name so we can see what we are having here. Oh yeah, sorry, I forgot to return here. Let's just return no for now. Okay, so you see that we have actually two problems. First one, our files are ending with .class, we need to replace that. And the second problem is, you can see that package that I'm talking about that we're building, but we're starting from classes and we need to start from com. So let's just fix the class extension first. That's an easy one. Replace constants Java binary extension with nothing. This should fix it, I think. Yeah. So now we need to fix this. Now I have an idea. If we start not from the root folder, but if we do something like this. So file list files for so if you call scandir to the inner file like that, we're going to get rid of this classes dot. So let's just run it and see if that's the case. Yeah, that's the case. So we're done here almost. Now we need to actually create a storage for those classes. So this time we're going to create it as a field because we're going to access it not only here but here as well. So set class like that. Let's create an instance class okay for directory like that. Okay, so here just to be sure, let's just call this located classes.clear. Not that we're going to call that method multiple times, but just to be sure. Now we need to return it, located classes, and here we need to say this located classes add class or name, class name. And about the exception, just add it like so. Add a try catch, just throw it. Also, I think it would be a little bit cleaner if we move it here like that. Okay, so let's run it and see if we manage to do it now. Okay, so yeah, as you can see, we managed to successfully scan all classes that are in this application. Okay, so let's just make one final test with the jar file to see if we are also managing to scan all files. So running it again. Yeah, you can see that we're successfully scanning it for both cases, for jar file and for directory. So with that being said, we are done with locating classes and we're moving to mapping them.